Problem number 2.15. A battery of voltage V is connected to a 30-watt bulb and a 60-watt bulb as shown in the figure. Identify the brightest bulb, then which bulb has a greater resistance. And third one, suppose the two bulbs are connected in series, then which bulb will glow brighter? Hope you should have understood. Or diagram. Let us draw the diagram initially. So the given circuit is drawn there. We are going to get answers for three questions. One is to identify the brightest bulb in that parallel combination. The second one is which bulb has a greater resistance in that parallel combination. And the third one asks this, in series combination, which bulb will be brighter? Let us consider the initial one, that is A. Identify the brightest bulb in parallel combination. See, we know that power P is equal to V into I in general. But in parallel combination, this potential or the voltage is considered to be constant. So if the voltage is considered to be constant, then I can write power is directly proportional to current. If the current is higher, then power is also higher. If power is higher, the bulb will be brighter. So when the current will be higher in a conductor or in a resistor, the current will be higher if the resistance is lower. Because we can prove like this. You replace I with V. I can write P is equal to V into, instead of I can put V by R. So P is equal to V square divided by R. I can write as V is constant. Potential difference is constant in parallel combination. In parallel combination, then I can say power is inversely proportional to resistance. So out of the two given bulbs, one of the bulb is 60 watt, another one is 30 watt. On comparison, 60 watt is higher than that of 30 watt. So higher power will have a lesser resistance. So 60 watt bulb is having a lower resistance. So current through 60 watt bulb is higher. So power is higher in 60 watt. So we are saying 60 watt bulb is brighter than what? 60 watt bulb is brighter than the brighter than the 30 watt in parallel combination. Okay, let us move on to the second one, B. Which bulb has the highest resistance, or which bulb is having the greater resistance? See, if you want to calculate resistance, what you have to do? To calculate resistance, okay, to calculate the resistance, let us consider like this. P is equal to V square divided by R. So from this, I can say P is directly proportional to 1 by R, or I can write the power is inversely proportional to resistance. Inversely proportional to resistance. So power is inversely proportional to resistance means the bulb with the lesser power will have a higher resistance. So the bulb with the lesser power will have higher resistance. The bulb with the higher or let us take like this. The bulb with the lower power will have higher resistance. The bulb with the lower power will have higher resistance because both are inversely proportional. Considered to have higher resistance. So which one is having the lower power? 30 watt bulb is lower than 60 watt. Is lower than 60 watt in power. Therefore 30 watt bulb is having more resistance or higher resistance, or having higher resistance or a greater resistance than what? Than 60 watt. Hope you should have understood. In case of series combination, the circuit can be drawn like this. See, in series combination, the current I that is flowing through the circuit is constant. As we know that power P is equal to V into I. If I is considered to be constant, then power is directly proportional to V. So if voltage drop or potential difference across the resistor is high, then power is also considered to be high. But we know that voltage is equal to current into resistance. That is what I have told. If the potential difference across the resistance V is found to be directly proportional to resistance. If the resistance is higher, because current is constant. If resistance is higher, voltage is also higher or potential difference is also higher. If so, the bulb will be brighter. In the given two bulbs, 30-watt bulb will be having more resistance than that of 60-watt bulb. Therefore, 30-watt bulb will have more amount of potential difference across it than 60-watt bulb. So 30-watt bulb will be glowing brighter than that of 60-watt bulb. Problem number 2.16. So in the page number 99, you are having another example problem, and that example problem is 2.16. Come on, let us go through that problem. Two electric bulbs marked 20 watt 220 volt, 100 watt 220 volt are connected in series to a 440 volt supply. Which bulb will be fused? So you are having two bulbs, and these two bulbs are connected in what? Connected in series with a potential difference of 440 volt. The first bulb, it was being represented as 20 watt 220 volt. This is, we are calling it out as power rating and current rating. And the second bulb, it was being given as 100 watt, and it works under the voltage of 220 volt. The question asked is, which bulb will be fused, will get fused? Because in both of the bulbs, the voltage rating is 220 volt, but the voltage connected is 440 volt. So which bulb can withstand and which bulb won't withstand? That was the question. So let us write like this: case 1, case 2. Let us write case 1. And in case 1, power is P1, which is 20 watt. Then voltage is V1, which is 220 volt. Similarly, I am considering case 2. P2 is considered to be 100 watt, and the voltage rating is 220 volt. They are connected with an potential, capital V, which is 440 volt. Yeah, so 440 volt. See, in order to calculate which bulb is getting fused, we have to calculate the potential difference across each and every bulb, because in series combination, current will be same, but the potential difference across the 20 watt will be different from that of the potential difference across 100 watt. If the potential difference across 20 watt is exceeding 220, then bulb 20 watt will get fused. If the potential difference across 400 watt is exceeding 100 watt, exceeding 220 volt means, then that bulb will get fused. That is the concept. So what I have to calculate? To determine the bulb to get fused, the bulb to get fused, potential difference across the bulbs has to be determined. Potential difference across the bulb should be got. So potential difference across the bulb, how I can able to get that value? We know that, see, this is a series combination. We know that power P is equal to V square divided by R, or the resistance R will be then equal to, or how I can write, V square divided by P. If it is so, what is this V1? Sorry, instead of this V, you can put V1 for the first one and V2 for the second one. See, what is this R? I can consider case 1. In case 1, what is R1? R1 is, that is the maximum resistance that is available. The bulb can work only in 220 volt. So instead of V, I am putting like this: V1 square divided by P1. What is V1? 220 into 220 divided by P1 is considered to be 20. So when you are simplifying, you will be able to get, so here you will be getting 0. 22 into 22 is 484. So 484 divided by 2, you will be getting 2420 ohm as the resistance. Similarly, for case 2, you calculate the resistance, because when you are calculating resistance, you can able to calculate the power or the voltage. V is equal to I into R. So you can get V2 square divided by P2. What is V2? It is the voltage rating for the second bulb is also 220. So 220 into 220 divided by 100. So two zeros we can be able to get cancelled. So 22 into 22, I can able to get it out as 484 ohm. In both of the, since both of the bulbs are connected in series, current is constant. Since both bulbs are in series, the current I is constant. I is constant. How to calculate current? Current available is equal to V divided by R. R, what is R? The total resistance in the circuit. So I am writing R total. What is R total? R total is nothing but the total resistance of the two bulbs. That is R1 plus R2. What is R1? 2420. What is R2? R2 is 484. Adding these two, I will be able to get it out as 2920 for a 404, 8 plus 2, 10, 4 plus 4, 8, 8 plus 1, 9, 2. So 2904 ohms as the total resistance. Now you substitute it here. Current I is, what is potential? Potential V is, the total potential connected is 440 volt. What is the total resistance? 2904. So you simplify this. I have simplified it with the help of the calculator, and the answer that I am getting is 0.151 ampere. So the current that is flowing through that circuit is 0.151 ampere. Now you calculate what is the potential difference across 20 watt bulb. So potential difference across 20 watt bulb is, let us write it out as V20. What is the formula? Current I into the resistance. What is current I? Current I is 0.151 multiplied it with, what is its resistance? Resistance is 2420. So when you are multiplying these two, you are getting the answer as, you just multiply. What will be your answer? Multiply pani pathingla. Now you just consider your answer. Multiply it and get me the answer. So when I am multiplying 0.151 into 2420, the voltage that I am getting is 365.42 volt. Similarly, I am calculating the potential difference across what? Potential difference across 100 watt bulb. So if it is so, V100 is equal to, current is 0.151, current is constant. What is the value of the resistance in case of 100 watt bulb? It is 484. So 484 multiplied with 0.151 is equal to 73.08. 73.084 volt. So from this we can say V, that is voltage across 20 watt bulb, is greater than 220 volt, because maximum voltage rating of the bulb is given in the bulb. Maximum voltage rating of the bulb given is how much? 220 volt. But here, what is the answer that we are getting? Here we are getting it as, we are getting voltage across 20 watt equal to 365.42, which is greater than 220 volt. So 20 watt bulb will get fused. 20 watt bulb will get fused in that series combination. Hope you should have understood what I have told here. You just take the problem again and you just try to work it out so that you can able to understand again. So it will be better if you are doing it again and again.